So yes, last year I talked about serverless Swift, last year I talked about server Swift. This year I'm going to be talking about serverless Swift. But before I start talking about serverless, I'm going to have a quick recap of the server components. So for server Swift, one of the reasons we see it as being so important is full stack development has really taken off with web developers. So just about 65% of web developers now consider themselves to be full stack developers. 25% of them consider themselves to be back-end developers, and actually only 11 to 12% consider themselves to be solely front-end developers. So for web development, full stack development has really taken off. And we're hoping and seeing that the same thing's happening in Swift. Part of that is because Swift is really fast. So it's about the same performance as Java. It's 4 times faster than Node.js, and it's something like 30 to 40 times faster than Ruby. And it's also really efficient. So Swift runs in under half the memory of Java and Node.js, and it runs in something like a quarter of the memory of Ruby. And that's really important if you're running servers in a cloud, because clouds charge you according to memory. So Swift on the serve really gives you these advantages of becoming a full stack developer, of having a fast back end and running efficiently in small amounts of memory and keeping your costs down. And this allows you to achieve this. Right? You have an iOS app that's talking to a Swift server. You have the ability to have authorization and push notifications and so on. And you have an end-to-end solution in Swift that if you wanted to, you can then start building web apps and Android front ends for as well. But you get that end-to-end experience for Swift. Now, one of the downsides of doing web development, and we heard this morning, is you have to start to kind of understand this. So when I create an interface in Swift code, I create a protocol, and I create some APIs, and I do that all in Swift code. The API between a client and a server is REST, and it's defined by something called Swagger, or the Open API spec. And this requires you to know about types of methods, so get, patch, put, delete, and post. And you have to define kind of your class hierarchy or your function hierarchy using names. So in this case, server meals. And then that receives arguments and sends a response like a normal programming language. So what this looks like on a server is this. Right? I import Katora and I import Swifty.json, although that will soon get replaced with Codable. And I have to create a route. So I can do all, which is all routes, and I can add a body parser middleware on that. That converts it into JSON, which again goes away with Codable. And I then have a callback that occurs when a given path is called. In this case, handle create. So I'm going to create some data with this. So I get a request and a response. The first thing I have to do is parse that JSON and check to see whether it's valid. At this point, I then pull out the fields and validate each of the fields of the JSON. And now, finally, I can actually do some real work. And at the end, I have to call next. So there's quite a lot of work I have to do validation and understand how those routes occur. Now, once I've built my application, I then have to deploy it. My first option is to do this in virtual machines in what's called infrastructure as a service. So it's designed that I don't have to worry about infrastructure. There's a slightly easier way of doing that, and that's in containers as a service, so Docker. So rather than having to think about full machines and operating systems and so on, I put it in a container which deals with that kind of level for me. There's an easier level, which is platform as a service. So in platform as a service, I don't care about the platform anymore. I just bring my application code. But what's being introduced now is a level that's one stage easier than that. So at every stage, the idea is you care less about the hardware that it's running on, the operating system that it's running on, and your life gets easier. But it also narrows your options. So as you go along this spectrum, the programming model gets easier. The concerns you have to worry about are less, but you also have less flexibility and less control. So what appears on the right-hand side is serverless. Following that as a service model, serverless is called functions as a service. So what's the difference between platform as a service and functions as a service? When you're doing platform as a service, and this is building a Katora backend and deploying it into a cloud, and function as a service is first the programming model. In Platform as a Service, I build a full application. In Serverless, I build events. So rather than a full application, I just build small event pieces of code. Other than that, the idea is you treat compute, as it's called, as a utility. So you pay for server time based by memory and how long you want it for. That's the same for both. And both of them should inherently provide you scaling and resilience and high availability and uptime, because that's what you get from deploying in a cloud. So does that mean the only difference between the two is the programming model? Well, not quite. In Platform as a Service, you deploy your server application, and it runs 24/7. Serverless is designed not to do that. If your application isn't actively doing anything, if no request has been made, it's not there. It's designed to spin up very quickly, ideally in less than 20 milliseconds, and only run when it's got something to do. So the idea of serverless and how it's different is it will run your application and then stop when there's no more work to do. And it's very efficient at bringing these up and shutting them down, which means if you've got a workload that only runs sporadically, you don't actually pay when it's not running and there's no users using it. Okay, so most of the available clouds have got some form of serverless. So Amazon Lambda, Google Cloud Functions, Azure Functions, and this final one, which is OpenWhisk. And OpenWhisk is an open source project in Apache, which is being backed by IBM and Red Hat and Adobe and a number of others. And the code examples I'll give you today are from OpenWhisk, because it's the implementation that added Swift support first and probably does the best job of implementing Swift. So, like any example, let's start with Hello World. So this is how you start to build an action. The first thing you do is you have your function call, which is just main. So all serverless actions are just a main function. You have a string any dictionary, which is your incoming parameters. And you return a string any dictionary. So very simple inputs, outputs of string any dictionaries, and every function you implement is main. So to do the Hello World version of this, I have a look at my incoming parameters, and I'm checking for a field called name and that I can convert it to a string. And if I get that string, then I'm going to do returning a greeting of hello and that name. And if I don't get anything I can use, I'll return hello stranger. So this has implemented something that's going to say hello, someone's name, or hello stranger, and that's a complete action. That's the entire code that I can then run on the server. So once I've done that, obviously I need to be able to run it somewhere. Now, there's two ways of doing that. The first thing you can do is you can get OpenWhisk from GitHub, and once you've downloaded it, you go into its provided directory and type vagrant up. What that's actually doing is starting a full Linux VM for you, and it runs OpenWhisk inside that VM, because OpenWhisk is itself a server. But the way you program doesn't require you to worry about the fact there's a server there. So a couple of quick commands, and I now have a server running on my machine, or I can deploy it to a cloud. In the case of OpenWhisk, one of the options is to run it under IBM Cloud Functions. So I've either got my Vagrant image running up, or I'm going to deploy it to a cloud. So I've got my Hello World. How do I actually register it so it can be run in that serverless framework? First thing I do is I run the Whisk CLI and say action create. So I want to create an action. I'm going to give the action a name, which is hello, and I'm going to give it my main.swift file. And that's it. Running that command will give me a registered action that can then be run. And if I want to list my actions, it shows me that it's been registered. So that gives me a registered action, but obviously it needs to be run. I can do that from the command line. I can do whisk action invoke. So this invokes my action. I can tell it I want a result back, and I want to call the action called hello. and I can send it the parameters I want it to use. So by sending it name and world, I'm sending in a string any dictionary with name and world in it, and hopefully I'll get hello world back. So when I run that, I get a JSON response, which is a greeting of hello world, which is what I programmed into my action. So that gives me hello world, but can I build something that's actually more complicated? Well, the system in which you build and run events in serverless is all around triggers. So events actually run asynchronously based on a trigger occurring. And there's a whole selection of different triggers. So some databases are able to kick off triggers when an update is made in that database. So new data arrives in a database, a field's deleted, or anything like that, you can kick off an event. You can do it through IoT sensors. So if you have a sensor that's connected using something like MQTT, then an event being sent from the IoT sensor is enough to be able to trigger serverless code. You can use webhook integrations in GitHub or Slack. And you can also use REST requests, so a standard web request of a server. So exactly what you would do during serverless. So what you're doing when you're building an application in serverless is you start by taking triggers, so events on which you want to do something. You then define your action, which is that main function that implements hello world or actually anything that you want to do in Swift code. You can put data in databases. You can send push notifications. Right? You can write any Swift code there that you would like that runs on a server. The only requirements for it is it's designed to be a single task. You have a string any input, and you have a string any return. So you have triggers and actions, and you have rules. And rules chain together triggers and actions. So you can say, when I get a REST request, I want to trigger this action. When there is a database update, I want to trigger this action. And actions are very simple. So what you can actually do is also have rules that say an action is composed of a whole number of other actions. So the design is to keep the actions nice and small and contained, like you would a function in your own code, and call that utility function from a number of other places. So you end up with these chains of actions being run together in order to achieve a more complicated outcome. And once you've got this, so you've got a rule which says a trigger causes a series of actions to occur, you can actually group these together, and you can have more than one of them, and you can put it together in a package. And that actually helps you build a full server-side application. So the bottom one there, I said you can build a REST request. So this helps me build a server-side application which has a web interface, so I can use URL session and URL requests from my client. Now, how do I actually expose that endpoint? So what you do here is you use another CLI command, which is whisk API create. That says I want to create an exposed API. I want to do it on /hello with the method of get. So this is back to our REST specification. So when there is a get request on /hello, I want to run my hello action, and I'm going to get a response type back of JSON. And this creates it for me. So this starts to build that Swagger definition of my REST APIs. So it's now registered on my host name, 9001, under API, some hashing, and then hello. And I can then use an API gateway to do a redirect so that I can have a normal-looking URL that pipes through to this. And once I've done that, I can use curl or any other utility to check that it's working. And that's how I start to compose this. So with a server, I write a single application that implements all of these routes, and I do it in code. With serverless, you build small components, and then as a deploy task, you actually build the same thing. So unfortunately, you can't get away from this sense of having to know about methods in routes. It's just that becomes a DevOps times problem rather than a code time problem. Now, in terms of invoking it, you can then make calls using URL session, but there's also a mobile SDK, and the mobile SDK is designed to simplify that task. So how this works is you build your set of parameters, and then you do an invoke action request. So you name the action that you want to call, you pass in the parameters, and you register a callback for your response. So in this case, I do some error checking, and I then get my reply back. So rather than having to worry from the client about calling a get or a post in the URL, I can just call the action directly. So this, again, is designed to simplify the thing. So finally, are there any real examples of people building serverless applications for iOS apps that have actually been released and are being used by huge numbers of users? Well, there's a few. One of them is an app in the App Store called Weather Gods. So Weather Gods is it's an interesting kind of weather notification app. So what you do with Weather Gods is you actually select your location, and rather than being designed so that you go and see what the weather is, it's very notification-based. So you select the locations that you care about, and the Weather Gods sends you notifications when there's a change in weather. Or you can do it on a time basis. So you can get a notification at 8 o'clock in the morning that tells you what the weather's going to be in your location. So it's a very kind of server-to-client push way of doing weather. Now, the way this works is on their back end, there's a 3-minute alarm that runs, and that alarm selects a number of users from a group, and it then does a query against weather data from the weather company. So it grabs a whole bunch of data for locations that people are interested in, and it checks for types of weather like rain and wind and fog. And when it identifies that those events are happening or about to happen in an area of interest, it sends out some alarm triggers, and those alarm triggers result in doing push notifications down to the client. So this is very kind of async. Based on something occurring periodically on the server and checking for a whole number of requirements, so basically running rules to check to see whether we need to fire a whole number of actions, it then ends up in push notifications being made of the client. So this is a very server-to-client focused experience. Now, there is kind of a good reason it's done this way. And you'll hopefully understand when I talk about another example, which is BluePick. And this is a sample and demo application that we built in IBM. So BluePick is designed to be a little bit like Instagram. It's a photo sharing example. It allows you to take a photo with your phone and upload it, socially share with other people. But when you upload it, it also does image recognition to spot artifacts inside it. It pulls weather information to talk about what the weather was at the time that the photo was taken, in the location it was taken, and so on. And the way that we built this is we have 2 front ends, an iOS app and a web app, and both of those are served by Kitora, so a Swift server backend. There's a very good reason for doing this. So when you saw with serverless, all of your events are called with a JSON payload, which is converted effectively to a string any dictionary, and you return a string any dictionary. So if I want to do a web app, how do I actually surface just the static web pages? Basically, you can't. You actually have to have some kind of static web server that you use, and then that web page can then call back to your serverless actions. So to have a web front end, we actually needed a server. The other reason for doing this is I said that the charge model for serverless is designed to be that when your application is idle, it actually shuts down and you don't pay for it. And the statement was, one of the differences between serverless and a PaaS is that, hey, if your PaaS can start up within 20 milliseconds, then call it serverless. Now, the key bit there is 20 milliseconds, and in fact, it can be a lot longer than that. There is a lag time that means if your serverless action has not been called recently, when the next request comes in, we actually have to spin up the server and deploy your action before we can run it. So there can be a user experience lag time. So at the moment, the user experience tier should really be something that does run 24/7 and is always there, ready to accept the next request. So we built the back end using Kitora, all in Swift code. And what Kitora does is when it receives a new photo through a secure gateway that's using a service called AppID, we store the image in an image store. So that's just an object store designed for binary data. And we store metadata about the file, so who it came from, that information about what the geolocation was, what the weather was, and so on. That goes into a Cloudant data store. Now, we also have push notifications because we said it's a social sharing website, so we can send a push notification to the friends and the contacts of someone who's just uploaded a photo to see that that's happened. So that's a part of the system that runs without any serverless components. But we also said that we have this background task that does image recognition, and it does gathering of weather data for the photo. And all of this is actually done asynchronously, right? It's almost a background batch job. So when a new photo is uploaded, metadata arrives in Cloudant, and Cloudant raises a trigger to Serverless to say, I've got new data. So we actually use a bunch of serverless triggers and actions here to then go and fetch weather data and to do image recognition. Now, we can still do this even if you're using things like ARKit in the client. And that's because one of the things that we found is ARKit is very good at image recognition quickly. When we run image recognition on the server, we can actually get much better results than we can on the client because we've got an infinite amount of resource that we can check against. We can check against a whole number of images loaded on the internet that isn't available in AR directly on your device. So what we can do is we have this background task that can add the weather data to it, and it can add additional image recognition data to what was sent up. And then that, in turn, can also notify the Kitora server to say that it's happened, and that then sends another push notification back to the client. So here we're using both server and serverless. And the reason that we're doing it is in the same spectrum that we had before. You have server applications. Now, they are a bit more complicated, and they are a bit more effort to develop and deploy, but you get a lot more control and you get a lot more flexibility. And then we had stuff that runs asynchronously and is actually event-based. And we can do that very easily in serverless. So you now have this kind of spectrum of options. You can either have a lot of control and create rich application backends that do exactly what you need them to do with a whole bunch of responsiveness criteria, or you can implement serverless, and you can have simplification of what you need to do so you don't have to worry about full applications. You just build actions and you can configure events in the way that they run together. Or you can do both, depending on the task that you're creating. The key thing is, just a year ago, Swift 3 was released, and that was the first release of Swift that formally had any support for Linux. And 1 year later, you don't just have one choice of how to build backends in Swift, you have two. And in fact, I'm expecting that to grow over time. Swift on the server has now really arrived, whether that's server, serverless, or both. Okay, thank you.
Thank you. About running code on Linux, we're going to have a talk tomorrow morning about that. So make sure to attend. Yeah, just one word. All the classroom teachers, if you can go backstage, you will jump on stage right after the questions.
We have lots and lots of questions, like massive number of questions. I guess we can like talk for half an hour. Unfortunately, we just have like 5-10 minutes at most. So try to make the best.
People are starting to be hungry.
Yes, and people start to be hungry. Yes. So a question from the audience. Do you know any other FAS other than OpenWhisk that can be used and they propose a product or a commercial service?
So there's a number of serverless providers, right? So you've got Amazon Lambdas, you've got Google Cloud Functions, you've got Amazon Cloud Functions, and you've got OpenWhisk. They all support Swift to some extent or the other because they're actually all designed that you can run any arbitrary binary. Some of them support Swift natively. OpenWhisk is one of those. If you want to use Swift with some of the others, you actually have to compile a binary and you just have to say, look, you just invoke its compiled name and that's it. And it has very little knowledge about what's inside it and how it works.
Yeah. What I understand with this function as a service is kind of some implementation of the approach which is called microservices, like splitting your code. And maybe it's a more general question, but we're not like server guys, but I'm not completely certain to understand what's the benefit of splitting your code that way, like using microservices instead of monolithic stuff.
So all of the arguments are exactly the same as to why you should write code where you have small functions. And you will often find that you write a small function, it gets used in many other functions. And that's because you've built reusable utility code. Now, a lot of the ideas of moving to microservices from large applications was much the same thing. It's about simplifying what's there, and then it makes it easier to update and replace things because they are small, focused pieces of code that have one task, and it's easy to understand what the task of that one thing is. So you can change it without breaking unintended side effects.
And you mean even like hot swapping them or things like that?
Yeah, so rather than having to change like and redeploy like 4 million lines of code when you want to change one line of code in your server.
On a Friday evening?
Yeah, yeah, which is when it always seems to happen, right? Then you've got the option of, you've got small components, you're only changing a small component, and actually serverless is now breaking it down again. But it's exactly what you do inside normal code, right? You break things down into small functions.
Yeah, and how would you manage persistence in those cases, like in microservice?
So the answer's the same as it is whether it's server or serverless. You use a database or a data store for it. So all persistence is offloaded to a different service.
Yeah, right.
Yeah, which can be seen also as almost a microservice on its own because you could like fetch it and query it from other microservices.
Yeah,
right?
This is where encapsulation comes in. So you generally have one microservice or one function that's responsible for dealing with a given database. So all access to that database goes through one route, and you can control it much more cleanly.
And maybe you can say a word about what you're preparing about that around the database with Kitura.
Yeah, so we've got some interesting stuff coming down the line with Kitura, particularly around how you program to it, and this is largely driven because of Codable.
Yeah.
So server-side programming has been very difficult because we transport everything with JSON, and JSON in Swift has been somewhat difficult. The introduction of Codable simplifies this no end. So we're looking at a new set of APIs being added to Kitura where when you receive a request, you don't receive a request object and a response object, and you have to drag JSON out of it, and you have to validate it, and you have to know that if your JSON's invalid, you should return an HTTP status 403. We'll do that for you. Your programming model will actually be, I want to receive a request from a client, and I want it to pass me this Swift strut or class. So I want to receive a user object, and I'm going to send back I don't know, an employee ID. Yeah.
That sounds really sexy, and if we can get that, it would be really, really interesting and remove a lot of code. About parameters, when you were talking about the function as a service, the example that you show is you actually kind of, it seems that you decouple the request from the actual implementation of the code, of the hello world code. But how do you make sure that the parameters of the request are matching what the function is expecting? Is there?
So serverless and the API that's there suffers from the same problem that Kitura does today, which is you receive this payload and you have to validate it yourself.
Which is really costly in terms of development, at least.
Yeah. So the way that we're going to fix that using Codable for Kitora will also be fixing for serverless. In fact, one of my main goals across the two projects is we want to get the APIs much closer together so that we don't want it to be you have to choose one or the other, right? If I start off with serverless and I want to actually build a full server, I should be able to just copy my code over, put it in the project, and it will run. And likewise, if you start off with a Kitora project and you decide that actually I'd much rather this was a serverless application, you can pick up your code, drop it into serverless with no code changes required.
And even like providing some code for the native iOS app.
Yeah, and we want to provide an SDK for iOS that just talks directly to the server without you having to worry about URL session and put and post and this stuff. You just call an API.
That actually, sorry, that reminds me of a question I was wondering is worrying about when you're starting writing some server using Swift. Is it going to be like really usable and easily usable for web apps? Like, okay, we will theoretically able to share code between the native app and the server, but what about the web front ends that could use this server-side Swift?
So making it easier for iOS and for Server Swift to talk together and share code doesn't mean it becomes more difficult for the other platforms. In fact, we already have a set of generators which will take a Kitora application and build SDKs for other languages.
Already, you have that?
So we already have building like a Ruby SDK or a JavaScript SDK or a Java SDK to use in Android. Right? We're already doing those pieces.
I haven't seen that.
Yeah. So I've been using OpenWhisk. Actually, to the audience, it's just not like hipster stuff. It works well. You can actually build like your first Slack app with OpenWhisk, and it works like a charm. I have a specific question about the product. Do you support scheduled events?
Yes. So one of the triggers is a timer. So you can fire a trigger at any time of day or on a like a 30-second or a minute basis or whatever, and then chain whatever actions you like off that trigger.
I don't really know what that is. Is it some kind of replacement of some cron that you would run on the server?
So if you wanted to have a scheduled cron job, yes, you can do that.
Okay, interesting. Just more of a strategic question is about IBM and why IBM is jumping into this Swift server-side adventure, you could even say. Can you tell us a word about that?
So there's a whole number of reasons that come together.
Yeah.
So one of them is IBM actually has a huge iOS development team. We have a couple of hundred people, I think it is, who are doing iOS development. And this is part of the partnership with Apple. So we help enterprises, so large companies, build iOS apps that work with their existing enterprise capabilities. They've got their own data systems. Like when their sellers go out to a customer, they want to have an app that knows about what products they can sell, what the price is, and this sort of stuff. So we've been helping customers build that for some time. And they themselves want to be building Swift backends because at the moment they have to have two teams. And they have one team that's building backends in other languages, and then they have the iOS front-end team. And that introduces scheduling problems, so they're trying to line up resource that's available on both sides for each project. And they really would like to move to a model where they have self-contained teams that build both parts. And that's what they've actually been doing. And we now have some server backends written in Swift on Kitora being delivered by that team.
Yeah, and you mean when you're building an enterprise app, you don't really need to have both worlds, like Android and iOS. You can be just iOS for all the
Yeah, it's a good model for them
device.
because lots of enterprises only really want to support one platform because it makes it easier for them to do security and that sort of stuff,
Makes sense.
Sorry?
Maybe we need to move on.
Yeah, I guess so.
Yeah, it would be a pleasure to continue the discussion. But Chris is there today and tomorrow. There's also going to be a classroom, but we're going to discuss about that in a moment, about Swift server-side. And make sure to jump to Chris afterwards during the breaks to continue the discussion. Thank you very much for your talk.